Hello everyone, welcome back to The Real Programmers. Today's topic is UML class diagrams. Let's get started with a quick introduction. When you start developing a new functionality in a system or a new system altogether, you might be tempted to dive into coding straight away, skipping the UML class diagrams, thinking that you can handle design patterns, object-oriented design, and solid principles as you go. While it might seem like a time saver, but skipping UML class diagrams can actually cost you more in the long run. In interviews, starting with a UML class diagram is always a good idea. It clearly shows different entities and their relationships, helping you communicate your design effectively before jumping into the code. And in real-life development, UML class diagrams are your best friends. They help you correctly identify and implement design patterns, which will ultimately save you from time-consuming refactoring later on in the development. In this video, we will be talking about basic building blocks of UML class diagrams, how to represent different class relationships in an UML class diagram, and in the end, a combined example. Within the basic blocks, we will cover class, attributes, methods, interfaces, abstract class, and enumeration. Next, we will learn about how to represent 6 different class relationships in a UML class diagram. And in the end, we will show you a combined example using an address book example. Let's start with the basic building blocks of UML class diagram. Suppose you are designing a system and you want to represent some entities in your system via UML class diagram. These entities are nothing but classes, interfaces in your object-oriented design. The first building block we will talk about is a class. From a system's perspective, a class is an element that defines the attributes and behaviors that an object of this class will generate. The behavior is essentially represented by the methods or operations offered by the class. The classes are represented by rectangles having typically 3 compartments. The first compartment contains the name of the class. The second compartment or the middle compartment contains the attributes of the class. Attributes represent the properties or data fields of a class. We will revisit this section to understand the different components and symbols used in this section. And the third compartment or the last compartment contains the methods or operations supported by the class. Methods or operations in a UML class diagram represent the functions or behaviors that a class can perform. Now, let's zoom into the entity. If I can give you an example from the perspective of a banking application, if I want to represent an account class, the name of the class account will go in the top compartment. Then in the middle compartment, the associated attributes like account number and balance. And lastly, in the third compartment, we can add the associated methods or operations, for example, deposit, withdraw, etc. You might be wondering about the symbols in the beginning of each attribute and methods. They represent the visibility of these attributes and methods. There are 4 symbols to denote 4 different types of visibilities in the object-oriented system design. The plus symbol is used to denote that the method or attribute is publicly accessible from any class. The minus or hyphen symbol is used to denote that the method or the attribute is private, which means that they are only visible within the same class. The hash symbol denotes that the attribute or the method is protected, and meaning they are only visible in the same class and its subclasses. And lastly, the tilde symbol denotes that the attribute or the method has a default visibility, which means they are accessible within the same package. Since we are now familiar about the visibility, we can now talk about the representation of attributes and methods in detail. If I zoom into the first attribute, account number, you will see that it starts with a minus symbol which represents the visibility, and then the name of the attribute, which is account number, then comes a colon, and lastly the type of attribute. If I zoom into one of the methods, withdraw, within the account class, it also starts with the visibility symbol, then the method name, then the arguments within the parenthesis, comma separated name, colon, and the type of argument. And if there are no arguments, then we can leave a blank parenthesis, then a colon, and finally the return type of the method. We have completed the basics. Now let's look at how abstract class is represented in a UML class diagram. An abstract class is a class that cannot be instantiated. Basically, you can't create objects directly from it. It serves as a blueprint for other classes, basically the subclasses that inherit from it. Suppose we have an abstract class called shape, then in the first compartment, we will add the keyword abstract within two angular brackets above the name of the class. The class attributes are represented in the same way as in normal classes. We start with a hyphen to indicate the private attribute and then the name color and its type string. In short, the two differences are that name of the abstract class and the abstract methods are typically shown in italics. Next, we will talk about interfaces. An interface defines a contract or agreement for the classes that implement it. It specifies a set of methods that implementing class must provide. So, in case of an interface, we usually have two compartments. The top compartment contains the keyword interface within two angular brackets and then the name of the interface, and in the bottom compartment, the methods or operations follow the same notation as in classes. Please note that the purpose of interface is to define a contract of publicly accessible methods that implementing class must provide. So, interfaces only contain public methods, and so all the methods start with a plus symbol in an interface. The last topic in basic building blocks is enumerations. An enumeration is a data type that defines a set of named values, for example, colors, days of the week, etc. This is called enum in short. Similar to interfaces, enums are also represented with two compartments. The first compartment features the keyword enumeration within two angular brackets and then the name of the enum class. The second compartment lists the named values each on a new line. This was all about the basic building blocks of a UML class diagram. Now let's move on to the next section. In this section, we will discuss about different relationships between classes and how they are represented in an UML class diagram. Please like the video and subscribe to the channel if you haven't done already. There are 6 main types of relationships between classes. First, association, and then aggregation. Then we have composition, and after that we have inheritance. Then implementation, which is also called realization, and lastly we have dependency. The typical arrows for each one of them is shown beside them. We will discuss each one of them one by one and also the variations in representation. Let's start with the first, association. Association is the most commonly used relationships between two classes, which indicates one class is related to another but not necessarily dependent. For example, cars and drivers. One car corresponds to a particular driver, and this is indicated by a simple connector joining the two classes. This is also called simple association. The relationship that a driver class drives a car can also be indicated by a directed arrow. To indicate multiplicity, for example, in this case, one driver can drive multiple cars. This multiplicity can be indicated like this: 1 written near the driver class and 1 ... star near the car class. Let's look at the next relationship called aggregation. Aggregation represents a has-a relationship, where one class contains another class, but the contained class can exist independently. For example, contact group class contains a list of contact class, and this is represented by a white diamond arrowhead pointing towards the class which contains the other class. A list of contact class is contained inside the contact group class, but contact class objects can exist even without contact group class. Multiplicity in case of aggregation can also be indicated same as in case of association. In this example, 1 is marked near the contact group class and 1 ... star near the contact class. This would mean that one contact group class can contain any number of contact class objects, but at least one object of contact class is required. The next UML relationship on the list is composition. Composition also represents a has a relationship similar to aggregation, where one class contains another class, but only difference is that the contained class cannot exist independently, and this is represented by a filled diamond arrowhead pointing towards the class which contains the other class. For example, an address book can have multiple contact groups, but a contact group cannot exist without an address book. Just like in aggregation, we can show multiplicity in composition using the same format. In the example, 1 is shown near the address book class and 0 star is shown near the contact group class. This means that one address book can have any number of contact groups, including none. Next, we will talk about another important UML class relationships called inheritance. Inheritance is also called generalization. This represents is a relationship or a parent-child relationship between classes. A parent class is also called a base class, and a subclass is also called a derived class. Subclasses inherits all the characteristics of the parent class, like attributes, methods, plus they can contain some additional information. This is represented by a solid line with filled triangular arrowhead, starting from the subclass and pointing towards the base class. For example, personal contact and business contact inherits from same contact class. Both the classes contain the common attributes and methods along with some additional attributes and methods specific to these classes. Next, we will talk about implementation, which is also called realization. Realization or implementation represents a relationship between a class and an interface, where the class implements an interface. An interface is a collection of methods and the class has to implement all the methods declared in the interface. This relationship is represented by a dashed line with a filled triangle starting from the class to the interface. For example, a rectangle class and a circle class implement the shape interface, which declares a getArea method. The last relationship we have on the list is dependency. This is a relationship where one class relies on another class in some way, often through method parameters, return types, or temporary associations. This is represented by a dashed line with an open arrowhead ending at the class which is used by another class. In this example, address book class depends on the owner class to get the owner information. Now, let's look at the combined example. This is an example showing a complete UML class diagram. This is an example of simple address book application. At its core, there is an address book class which has a dependency relationship with the owner class to get the owner information. Further, the address book class contains a list of contacts and contact group classes, which are composition relationships. There are two types of contacts, a personal contact and a business contact class. Both these classes inherit from the contact class. And lastly, the contact group class contains list of contacts, and this is an aggregation relationship as the contacts can exist in the address book even if there is no contact group. This is all I wanted to cover today. Hope you find the video helpful. Please leave your comments and like and subscribe to the channel. Thank you, and I will see you in the next video.